All right, so we have a couple of warm-up problems that we're going to be multiplying together. So our first one is x plus 4 and x minus 4. Look at the next one, 5x plus 1, 5x minus 1, and then 2a plus 3b, 2a minus 3b. So what trend do you see going on here? Yeah, it's the same factor, except one has a plus in the middle and one has a minus in the middle, right? So let's see what math magic that does for us, Dion. Let's see what math magic is about to happen. So here when we multiply, I'm going to distribute this x to both pieces. X times x gives me x squared. X times negative 4 gives us negative 4x. And we're going to distribute the 4. 4 times x and 4 times negative 4. So 4 times x gives me positive 4x. 4 times negative 4 is negative 16. So what math magic do you think is going to happen? Why is that special? Yeah, what happens when you combine the 2 in the middle? What is negative 4 plus 4? It's 0, right? They cancel. So all I have left over is x squared minus 16. That's it. Do you think that'll happen every time? You hope so? I hope so too. Let's see. All right, what is 5x times 5x? Oh, we're multiplying. There you go. Yep. And what's 5x times negative 1? Now I have 1 times 5x. So positive 5x. And 1 times negative 1? What kind of a 1? A negative 1. Good. All right, did it happen again? Do we have, look at that, negative 5 plus 5? Does that give me 0? Yeah, so they cancel. What do we have left? All right. Nice. All right, my next one has an extra letter going on. You think that's going to change our math magic? I hope not. Let's see. What is 2a times 2a? 4a squared. Good. What is 2a times negative 3b? Negative 6ab. Good. What is 3b times 2a? Positive 6ab. Good. And then what's 3b times negative 3b?
Negative 9b squared.
There you go. Good. All right, did math magic still happen for me? Do we have negative 6ab plus 6ab? Does that cancel? Yep, so we're left with 4a squared minus 9b squared. Right? So yes, this is math magic. This is how we get the result called a difference of squares. The word difference means subtract, right? See how all of my answers have a minus? They all have a minus. And the beginning and the end are two perfect squares. Every time. Okay? What is the square root of x squared? X. What's the square root of 16? 4. Look at how it started. X plus 4, x minus 4. Right? What's the square root of 25x squared? 5x. What's the square root of 1? 1. So did I have 5x plus 1, 5x minus 1? Yes. Okay. So the rule we're going to follow, if I am working backwards, okay, I have two perfect squares with a minus sign in the middle. That's important. It's called a difference of squares. It has to have a minus sign. We're going to use the rule a plus b times a minus b. I know the TV is having a seizure, I think. A plus b times a minus b. Okay, so you take the square root of the first term, right? The square root of the last term, and then you add and subtract. Okay. We can always check by foiling. If we need to, like we did in the beginning, we could foil them real quick and make sure they cancel out. Okay. What happens, do you think, if there's a plus in the middle? Would we get the same pattern? No, it would not, okay? We would call that prime because you have not learned about imaginary numbers yet, okay? You will. Eventually, those will be doable, but in Algebra 2. So for now, if you have a sum of squares, right now you can't do it. So you would just say it's prime, okay? So let's work through the odds together. And then whatever is left, you will be responsible for your evens. All right. Okay, here we go. We have a squared minus 4. Let's check, is it a difference of two perfect squares? Is there a minus sign? Yes. Is a squared a perfect square? Yes. Is 4 a perfect square? Yes. So this is an example of a difference of squares where I'm going to have the exact same thing, but one's going to be a plus and one's going to be a minus. All right. You said a squared is a perfect square. What is the square root of a squared? Just a. And what is the square root of 4?
2.
And we're done.
Oh,
That's it. That's it. The end. I have my 2 factors. Okay. So how are these different from all the other ones we did last week? A little easier. Yes, I agree. I like them a lot. That's why they're special, because, they can't. It's not always going to. Not yet. You haven't turned the paper over yet. Notice they all only have 2 pieces, right? Last week we had either 3 or 4. These just have 2. Okay. Yeah, they weren't bad. It's just when you take your test on Thursday, that's something you could probably notice really, really quick right away is how many pieces are there. Are there 2 pieces, 3 pieces, or 4 pieces? And then that kind of helps you decide which method you're going to use to factor it. Okay. Google, there's certain ones that have to work a certain way. Yeah, so you pick, but there's only one way to pick. That makes sense? So, all right, 81 minus x squared. Is it a difference? Is it a difference? You're already doing it. Is there a minus sign? Yes. Yes, a difference means minus. We're good. Subtraction. Is 81 a perfect square? Yes. Is x squared a perfect square? Yes. What is the square root of 81? 9. What is the square root of x? Or sorry, what is the square root of x squared? X. So we have 9 plus x and we have 9 minus x. If you write x plus 9 and x minus 9, you would be wrong. Order does matter. See how 81 comes first and then it's subtracting x squared from it? That does matter, okay? So make sure you keep it in the same order. All right, number 5. Is this a difference of 2 perfect squares? No. Why not? What's wrong with it? There's a plus sign. This is a sum of squares. You don't know how to do that yet, okay? So because of this guy, right now we can't do it, so what do we call it? We're going to call it prime. All right, number 7. We have 9b squared minus 100. Is it a difference? Is it subtraction? Yes. Is 9b squared a perfect square? Is 100 a perfect square? Yes. All right, so let's do this. 3. Good. And then, there you go. Good. Is anyone confused where 3b or 10 came from? Okay, so it's the square root of each piece. The square root of 9 is 3. The square root of b squared is b. And then the square root of 100 is 10. Yep. If you need to make a list of perfect squares on this side, you're more than welcome to. 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared, 5 squared, 6 squared, 7 squared, 8 squared, 9 squared, 10 squared, 11 squared, 12 squared. I don't think you have to go above that. But if you want to write your list real quick of perfect squares to be able to recognize them quicker, go for it. Okay, so number 9, is that a difference of 2 perfect squares?
Yes.
Yes, it absolutely is. What is the square root of 16a squared? 4 what? 4a, good. And what is the square root of 121? 11. What's going to go in between them?
The plus and the minus.
Good. One gets a plus and one gets a minus. Good. If that A had a power of 3, would that mess the whole thing up? Yes, it absolutely would. That would not be a perfect square. If the A had a power of 4, that would be okay. Okay, so if you have an even exponent, that is a perfect square. Yes, sir.
Which one you put the minus?
It doesn't matter. If you have 4A minus 11 and then 4A plus 11, that's okay. Yep. Good question. Okay. 4H squared minus 25G squared. Is this going to work? Yes, it is. Good. What is the square root of 4? What's the square root of H squared? Hold on. What's the square root of H squared? H. There you go. Now, what's the square root of 25? What's the square root of G squared? There you go. So we have 2H and 5G. One of them plus, one of them minus. Are we getting the hang of it? Yeah? Okay. Good. Is 13 going to trick you, or you think you got 13? You think you can do 13? I think you can. Try it. Take a stab at it. See if you can do 13. Kaylee, is that high enough? Okay. Okay. Try 13. There's a minus sign, so that's good. So far, you can keep going. They are both perfect squares. Emma, we are doing number 13. And then don't forget the second part, though. Has to be plus something minus something.
Oh, no.
All right. All right, Gabby. What did you get? XY plus 1, XY minus 1. Bless you. How do we feel about that? Good. Good. Excellent. Yep, let's go to the back. More math magic is happening for us. All right, number 15. Is there a subtraction in the middle? Yes, so far so good. Is 4C squared a perfect square? Yes. Is 5D squared a perfect square? No. What messed it all up? The 5. Just because of that 5, what do we say? We say prime. We can't do this one. Okay, this 5 right here is not a perfect square. That messed it up. If it was a 9, that'd be cool, or a 16, or a 64, okay? But 5, I cannot do the square root of 5. Yeah, all of your factoring will be on the test. You're going to have a little bit of everything. So you're going to have just the GCF, basic factoring, slip and slide, grouping, and then this stuff. Yeah. It might be. It might be. It's always nice to check. All right, k to the power of 6 minus 16. It's not finalized yet, so I'll give you a better answer when it's finalized. So I'll let you know if you need to look out for it or not. All right, is there a minus sign? Yes. Let's see if you're paying attention. Is k to the power of 6 a perfect square?
Yes.
Yes. What did I say earlier? As long as it's what? As long as it's an even number, it is a perfect square. What do you think the square root of k to the power of 6 is? K3. There you go. Good. All right, and what is the square root of 16? 4. Good. Nice. So as long as we have an even exponent, you can split it in 2. Bless you. Good. I'm going to kind of jump down over here to 20 just because I want to. Look at 20. See how it's 64 into the fourth and then 9 n squared? Is that a difference of squares? Yes. 64 and 9, perfect squared numbers, right? Both exponents are even numbers. So you can do number 20. Okay?
Well, when 16 and 18 be fine.
Hmm?
When 16 and 18 be fine.
No. Nope. You can do 16, 18, and 20.
Because when you square 49, it gives you
Square root. Square root 49. Yep, go the other way. All right, number 9. Let me do 19, though. Is this a difference of two perfect squares? Okay, so then what's the square root of 121 r to the power of 6? 11 r third. Okay. What is the square root of 1? There you go. So 1, there's a plus 1, there's a minus 1. Good. Okay. Now we got things like 21, 23, 25, 27, 29. Oh, we got lots of them. Okay. It gives me a hint. It tells me to look for the GCF first. Because right now, I mean, I like a squared and b squared. Those are perfect squares, but I don't like the numbers 24 and 54, right? So without doing anything else, right now, I can't factor this. But what can you divide out of both of those numbers? A 6? Yeah. All right, 24 divided by 6 gives me 4, and then 54 divided by 6 gives us 9, right? So if we divide the entire thing by by 6 first, we get 6 times 4a squared minus 9b squared. Do we like that better? Yeah, because now 4 and 9, that was part of my perfect square list. Okay. What do I do with the 6? Keep it there. Yeah, it's just going to stay out front. Okay. And what are our two factors going to be?
2A and
3b, good. 1 plus, 1 minus. There we go. So all we're doing down here in this bottom section is we're dividing it by something first before we do difference of squares. There's a little step in front. There's a reason why we did GCF the very first day, right? Because we've used it every day since. Okay. 43 looks all kinds of messed up. I don't like the numbers 45 or 20. I also don't like Q3 or Q, right? They have odd powers, not even powers. So what can we divide out of these guys? Okay, the number 5 can definitely be divided out. I agree. That doesn't help me with my Q's, though. Is there anything else they both share? Yeah, let's take out a Q. Because if 5Q comes out, we're left with what? 45 divided by 5 is 9. Q3 divided by Q gives me Q2. We like that. Negative 20 divided by 5 is negative 4. The only Q I had, I already divided it out. There we go. I like that better. Those are two perfect squares being subtracted from each other. So what is the square root of 9Q squared? 3Q. And then the square root of 4 is 2. Am I missing something? My 5Q needs to still be out front. Good. Fun fact, that power of 3 means that this graph is crossing the x-axis in 3 different spaces. See how I have 3 different Q's in my answer? Each one of those gives us a different spot on the x-axis of where it's touching. That's what we're going to use next week. So we're going to do all of this And then we have more to do afterwards to find where it's crossing the x-axis. Yay! I know. I told you it all builds. Yeah, good question. So 25, I like the number 100, right? I like the number 36. That's not my problem. What's the problem with 25? The b's. Yeah, b3 and I have b to the power of 1. So what can we divide out of this?
4? No, 2.
My numbers are fine. What is it? We're going to take out just a b. Just take a b out. Oh, we could take a 4 out, can't we?
Yeah, it's 25.
You could also do a 4. No, good call. Yep, good call. That would be the greatest common factor, which is what we're supposed to do. Yeah, good. So if 4b comes out, what's left inside?
5 and 9.
There you go. And 9. Good, which I still like that, because aren't 25 and 9 still perfect squares? So it still works out for me. What's our factored form going to look like?
5b
Mm-hmm.
minus 3.
Okay, there you go. Nice. Okay. If you had not taken the 4 out, you would have had the b out front, right? You would have had 10b minus 6 and 10b plus 6. But what can you divide out of each of those factors? The number 2, right? If I take 2 out twice, isn't that 4? So I could have just done the 4 in the very beginning. Okay, so you can do it this way, you're just not done. You have to keep working. So that's why getting the greatest common factor actually gives you the less work. By 8 and what? You can't do 2 different numbers. You can only do the same number. Oh, which one? Okay. Well, you want the greatest common factor, so I would do the 8. Yep. Is the only thing we're going to divide this by is 8? What else? A y also. So an 8 and a y are going to be a factor out of this one. So if I take out 8 and y, my first piece is now just an x squared. My second term, negative 32 over 8 gives me negative 4. y3 divided by y, I'm left with y2. Yep, 4y squared. Can I continue with this problem? Is there a more I can do? Yes, that is now a difference of 2 perfect squares. I have a minus sign. X squared, 4, and y squared are all perfect squared numbers or variables. Okay. So what is the square root of x? Oh, dang it. What is the square root of x squared? Did again. X. You're welcome. What is the square root of 4y squared? 2y. Is this my final answer? I can put a box around it, tie it with a bow. Thank you. I forgot my 8y. Now I can box it up and tie it with a bow. Now it's ready. All right. 29 does not look enjoyable, does it? No. 3n squared minus 147. Well, we have a minus sign, so it might work, right? If it was a plus sign, we could go ahead and say no. There's no point moving on. But there is a minus sign, so let's try. I like n squared, but I don't like 3 or 147. So I would try to divide by 3. That's our only hope. Does that work? 147 divided by 3 gives us, ooh, do we like the number 49? Yeah, we do. Okay, so 3. What's our new binomial after you take the 3 out? After that first, n squared. There you go, good. And then from here, can we keep going now? Yes, I like that much better. So what's our answer going to be? All right, I hear n plus 7, n minus 7, that's it. Don't forget your 3. Box it up and tie it with a bow. Yes. Sweet. How many we got left? 2 more. Okay. We got this. You're going to have all the examples. Oh, yeah. I think so. All right, 31. Number 31. I have m cubed n minus mn. So, there you go.
What you'd be left with just m squared.
Okay. So Kaylee wants to take out an m and an n from both pieces. You all cool with that? Yeah. M and n, m and n. So that gives me m n times, what's that first piece going to be left with? Just an m squared. Good. And what's that second piece going to be left with? A negative 1. Good. Right? Because if we divide something by itself, we're left with a 1. 2 divided by 2 is 1, right? Negative 2 divided by 2 is negative 1. So think of it that way. This is negative mn divided by mn. We get negative 1. All right, can we continue with this one? Yeah. I heard mn. Yep. There you go. So pretty repetitive. Each of these does have something a little bit different about it, but for the most part, hopefully you're seeing and feeling good about it. And then I'm going to throw something at you like number 33 and make you question your confidence altogether. I know, right? How awful of me. Okay. So when you get a crazy problem like this, okay, I look at this and okay, there's 2 pieces and there's a minus sign. So let me try difference of squares. I don't like 80 or 125, so there must be hopefully a greatest common factor we can divide out of each piece. Okay. So what do we want to take out? I heard someone say 5. Y'all cool with 5? Okay, 5. Good. And n squared. So they both have an n, right? We have n4 and n squared. So I can take n squared out of both of them. Good. Okay, let's see if this helps me. What is 80 divided by 5?
16.
That's a good number. We like that number. So 5n squared's out here. We're left with 16. What's n4 divided by n squared?
Wait, it's n2?
Yep, n2. Good. What is 125 divided by 5?
45.
Do we like that number? Yes, we do. Is it n the only n squared we already took away, right? Close it off. Okay, that looks much more doable. Just 4n. There you go. 4n what? There you go. Don't forget your 5n squared out front. Box it up, tie it with a bow. Good. Still feel good about it? So look, you've seen every version of difference of squares. You've seen it super simple. You've seen number 33 where the most of it is involved. You've seen examples of prime difference of squares because there was a plus sign, can't do it. Or, which one was it? It was up here, number 15. We had the minus sign, but the issue there was the 5, right? So you have examples of everything that you might see today or on your test on Thursday. So rest of class, go ahead and work through your evens. Okay?